We're looking at finding x-intercepts with quadratics. The first equation I want to show you is y equals x squared plus 3x plus 2. When we want to find x-intercepts, we're going to let the y equal 0. So we substitute 0 for the y. So we have 0 equals x squared plus 3x plus 2. What we would try to do is to factor the trinomial. In this case, when we try to factor, we look at factors of 2, which are 1 and 2. Factors of x are x and x. The 1 and 2 do add up to be the middle term, so there is a plus and a plus with the factors. We set each of the factors equal to 0 and solve for the x. So x is -1 or x is -2. In this case, the x-intercepts also tells us where the graph crosses the x-axis. So the x-intercepts, x equals -1, x equals -2, gives us the points -1, 0, and the point -2, 0. So these are points that we know are on that quadratic graph. If we put this equation in vertex form, we'd also have the vertex, so that would give us 3 points to use to graph that quadratic. The second equation that I want to show you is y equals x squared plus 4. When we substitute 0 for the y, x squared plus 4 cannot be factored. So another technique we might use is to subtract 4 from both sides. And we'd have -4 equals x squared, and we take the square root of both sides. In this case, you can't take the square root of a -4, so that means that that is impossible. It was impossible to factor, so that would tell us that this graph does not cross the x-axis. So there are no x-intercepts. And again, if we graphed it with our graphing calculator, we could visually see that very quickly. And we would know mathematically we could not find an x-intercept. A third example that I'm going to show you, y equals x squared plus 3x plus 1. Again, we substitute the 0 for the y, and we're going to try to factor this trinomial. When we look at factors of 1, there is no way we're going to get that middle term, so this trinomial cannot be factored. We can't move it across and do the square root technique either. So our third option is to look at the quadratic formula. So this is also a technique to use to solve, to find x-intercepts. Just to refresh your mind, this means we would do x equals -b plus or minus the square root of b squared minus 4 times a times c all over 2 times a. Our values a, b, and c come from the coefficients in our quadratic. So a is 1, b is 3, and c is 1 in this particular problem. So substituting those values, we have the opposite of 3 plus or minus the square root of 3 squared minus 4 times a, which is 1, times c, which is 1, all over 2 times 1. Now I recommend that you complete or do the arithmetic under the radical first. So we have x equals -3 plus or minus the square root of 9 minus 4 times 1 would be 4. Of course, we can do this multiplication in the denominator. That's pretty easy to do. And then we have 9 minus 4, which is 5. So negative 3 plus or minus the square root of 5 over 2. Now the square root of 5 is not a perfect square, so that does give us a decimal. But we would get two answers, this plus or minus. We would do 3 plus the square root of 5 over 2, or 3 minus the square root of 5 over 2. And then you could change that square root of 5 to the decimal and work that out. 3 plus the decimal value, 3 minus the decimal value, divide it by 2 to get your decimal approximations. So that gives you the 3 techniques to basically use to find your x-intercepts with quadratics.